Okay, so in this situation, what we have is two functions, and the question would ask to find the area between the two curves. So I'm finding the area between them. So if I were to graph these, it would look like this. And what they're asking me to find is this area between the red and blue one, that like part of a semicircle. Cool? Now an integral is how we find area. So we're going to integrate these. And the way we do that is we're going to do the integral of the upper function, the one that's on top, minus the integral of the lower function. The first step is to figure out what my boundaries are. If I want the area between the two curves, what do you think the boundaries would be? Like, where would they be? Like, not necessarily a number, but what? Go ahead, Victor.
Where the lines intersect with each other.
Yeah, so the first step that I have to do is find these x values of the intersection. So you can do that in your calculator or by setting them equal to each other. So go ahead and do that now. So y equals, type in y1, type in y2, figure out where they intersect. What did y'all get for your x values?
About 1.9. Probably 1.9 for the bottom one.
I got 2 point, yeah, that's what I got.
Okay. So we have negative 2.898. Was that right? Yeah. Okay. And then what was the other one, Victor? Did you?
1.9.
Okay. So now I have my boundaries. You'll notice that I put this entire second function in parentheses so that I remember to distribute the negative. You can do this one of two ways. If it helps you, you can integrate it like this and like basically keep it as one function, or this is the same thing as saying the integral of negative 2x dx from the boundary to the boundary minus the integral from a to b of 2x squared minus 11. Either one, it's the same thing. Like you can split them into two. Whichever one you prefer to do.
Which one do you think is easier?
I think it depends on the functions.
Okay.
Sometimes, like if you have, maybe this is negative 2x and this is cosine x, I think it's easier to kind of separate them into two things. But with this one, I would typically just leave it as one. So now, when I integrate these, this is the same thing as, I'm just gonna, here, this would be minus 2x squared plus 11 when I distribute the negative. Is that okay? Okay, so now, what would the integral be? For the first term, I add 1, so I get x squared. But then I have to divide negative 2 by 2, so I'm just left with negative x squared.
Wait, this also. Can you explain what you did?
I'm integrating just this piece right here.
Okay.
And then the next one, I would add one, so I have -2/3 x cubed plus 11x with the bar from -2.898 to 1.9. And then you plug in upper minus lower.
Wait, that's it?
That's it. The other thing, Victor, depending on your calculator, some of your calculators can calculate the area between the curve for you. Some of your calculators, that's the other reason to know why you can split it, is you can calculate the first area in your calculator and then calculate the second area in your calculator and do the first one minus the second one.
Okay.
That's the only other reason to know why to split them. Not too bad, right? I didn't think so.
And then upper function minus lower function is just.
We did it all in one step.
Wait, so is the answer, we just gotta plug in.
Yeah. So then you would do -1.9 squared
No.
minus 2/3, yada, yada, yada. I'm not gonna write it all out with my finger, it takes too long. Not too bad of a lesson, right?
Could have been worse.
Could have been worse.
So it's just these three things?
Okay, so again, the wording for an IB question would be calculate the area between f of x and g of x. HL, we add one more step to this called revolutions, meaning I can create a disk or a washer using this concept.
I don't want to get into this.
All you have to do is add pi r squared. Again, it's just more, not really harder, it's just more. Okay, everybody okay?
No.
All right, I'm gonna stop the recording. I'll post this with the notes.